Hello, my name is Eunsan. I'm a PhD student at Seoul National University. I'd like to present our paper MoDA, Map Style Transfer for Self-Supervised Domain Adaptation of Embodied Agents. The main goal of our paper is to adapt a pre-trained embodied agent to a new domain. First, we train a visual navigation agent in a noiseless simulator given the ground truth labels. Then we transfer the agent to a new noisy environment with both visual and dynamics corruptions with MoDA. MoDA is an online and completely self-supervised domain adaptation method that we suggest. The key idea is to encourage the inherent regularities of indoor scenes on the maps estimated by the agent. We evaluate our domain adaptation method in 3 different environments. The dynamics corruptions exist as actuation and odometry noise, and 3 different visual corruptions, the speckle noise, low lighting, and large scene scale are present in the scenes. MoDA builds on a conventional map-based visual navigation agent. At each step, an RGB observation and odometry sensor reading are given to the agent, and the agent predicts an egocentric map and its current pose. The global map is then generated by patching the ego maps transformed by the pose. Lastly, the policy is trained to output an action based on the map-based memory. The benefit of the structure is that we can decouple the mapping and localization models from the policy with the intermediate map memory. When the pre-trained agent is deployed in a shifted domain with visual and dynamics corruptions, our method only fine-tunes the mapping and localization model by enforcing the ego map and global map to be similar to the style-transferred maps. To generate the style-transferred maps, we adopt the Unpaired image-to-image translation network. The main goal is to learn the structural regularities of indoor scenes from the collection of ground truth maps, and translate the learned characteristics into the collection of noisy maps in the absence of paired data. So MoDA learns 2 map-to-map translation networks. First, the ego style transfer network to help the agent learn the detailed visual structure from the egocentric maps. Second, the global style transfer network to enforce the globally coherent structure over long horizon navigation. For efficient training process, we also suggest a sequential learning curriculum. Our agent first collects maps from the deployed environment, then we fine-tune the agent's mapping model for visual domain adaptation. Here we suggest 2 loss functions. First, the ego style transfer loss. As mentioned previously, we enforce the predicted ego map to be similar to the style transferred map using the ego style transfer network. Second, when an RGB observation and its flipped image are given to the agent, we expect the predicted maps to be the same but flipped. We designed a flip consistency loss which guide the agent to make such consistent map predictions. Finally, the agent is trained for dynamics domain adaptation. The localization model is fine-tuned with global style transfer loss and temporal consistency loss. We formulate the global style transfer loss using the global style transfer network mentioned earlier. It is similar to the ego style transfer loss, but the loss is computed between the predicted global map and its style transferred map. Additionally, with temporal consistency loss, the agent is encouraged to generate consistent global maps over a trajectory. Because the dynamics noise accumulates over time, we encourage the agent to learn from the global map generated from the previous time step. Here's the demo video tested on a newly seen Gibson scene with dynamics corruptions. The pre-trained agent from a noiseless simulator is deployed directly to the new scene. Our agent MoDA is also deployed in the same scene but adapting to the new environment in a self-supervised and online manner. As you can see, MoDA successfully demonstrates the improved localization and mapping performance on the test scene. Thank you for your attention and feel free to contact us if you have any questions.